Hello, and hope you're having a good weekend. My name is Keith Travis. I'm competing with the intention of going into an undergraduate degree for the game development, and then in hopes that your new artificial intelligence focus in the computer science will come around and be on campus. And then to cap that all off with a master's in game design. And really love the people at Full Sail. Heard about the university 10 years ago, finally made it out here, and I am just absolutely hooked. And also about 5 weeks ago, went to the Kennedy Space Center, discovered AI, have been working like mad with prompt engineering to help bring my coding up to spec. And well, I got a lot to show you. Let's get this show on the road. So what we have in that cover image, that background image on the Zoom, a lot of structure, a lot of granularity, and you can see deeply into this image. And if you've got much experience with generating images from AI, you're going to know that, yeah, it's going to be really hard for it to duplicate that. It would probably be able to give an excellent verbal description and pinpoint and highlight and talk about and identify all kinds of things that are going on in there and what they're likely to be. But even no matter how much you asked it to describe it, to, let's say, you or I, we might not be able to imagine it unless we already knew what was going on. Same thing if it tried to describe it to, let's say, another AI to generate an image. So what we're focusing on here are these cases where, especially with something like organic systems, biological systems more specifically, we get this loss of granularity. It's easier to maintain for the other sciences, but more difficult for biological systems. We're going to be using a lot of resources for this. We're going to be using, let's see, that was about 100 iterations right there. Okay, we're going to be using a bunch of API keys with ChatGPT to go round robin on a few things that you're going to see soon. We're going to be using some compression for images, and we're going to be using Google Vision API key. And what are we looking for? What are we doing? Here is what you're going to receive, among other things. You're going to receive a spreadsheet. You're going to receive a folder that has that spreadsheet and a bunch of other folders in it. I'm going to show you how we're going to put that to use. Up here, we're going to take the links, the sharing links from each of these folders, and you can use your own once you know what's going on. I've put those links all up here so it's easy for you to copy and paste. Now, just for the sake of time, these have check marks just to say we've gone through everything once, and that's fine. In fact, it's okay. If you have a few minutes, we can go ahead and open up a new one just to make sure we know everything's fresh. We'll just say new. All right, we'll open that up, and this is what you'll receive through your link. You'll be just getting this user interface on test mode, and it's going to be all blank, and you'll be able to take this thing right here and say, okay, let's copy and paste these over. You can use your own folders, that's fine. Once you see what's going on, you'll realize, okay, all of these are blank, except for one that has some images in it, except for today. It only has one image in it. That spreadsheet, this is a link to the same spreadsheet I'm using right here. I want you to count with me. Notice how there are 11 minus this top row. There are 10 entries here. These entries are all based upon the same image, the image of this guy right here, this clownfish kind of swimming around. Why is that? What are we doing here? You'll find out soon. We also had another spreadsheet showed up. I'm going to delete that. Okay, get rid of that. Get rid of this info right here. We're going to get rid of this guy, that guy. We have our source folder right here. He's just got that image in it. You can put as many images as you like. We have our compression folder right here. Let's throw that in the trash. JSON folder right here. Throw that guy in the trash. You're going to see where they came from soon enough. And then a bunch of fish over here. Why do we have a bunch of fish? Okay, let's get rid of these guys. There we go. We're going to see them or something very much like them again soon. Remember, there was 10 of those in the field before. We might not get 10 again. Let's see. And that can be a good thing. So the code itself, as you pace along with me, we're not going to look much at the code. The code is left to right in the same order of main functions as you see these 11 main functions. This is not much of a game, but these were my own personal boss battles, getting through each of these modules set out to accomplish what you'll see in a moment. So, what are we doing? Well, we were talking about granularity, and we can see all the time with AI that it is able to take an image like this and pinpoint and understand things and tell you all about it. But then when you ask it to find something similar or create something similar, it'll go mega simple or it'll go mega hallucination. In this case, we got pretty close. We had some, this was not generated by AI so far as I know. We have filamentous bacteria here. We have some strong circular structure, and that's what we care more about, is preserving structure. And so we go down, we say, give me a rich description, and it does so. It's amazing. And I say, okay, generate an image of it, and it gives me this. And we're like, okay, that fine-tuned branching kind of blubbed out those fine, sharp circular structures. Those are starting to blub out, but it's actually kind of close. Now, if we ask this guy to give us a rich description of, let's say, this image right here, he will do so. If we feed that back into him or ask him for a similar image, we're very likely to get a hallucination like this. Now, if we give that to Grok, who can draw nice galaxies, Grok will actually retain a lot of the verbalized structure. It will actually be able to incorporate that back into retaining a degree of structure into an image without ever having seen the original image, which is very interesting. But if I take this very fine-grained picture right here, even Grok says, you know what? I can tell you all about it, but I'm going to turn it into this rainbow party here. And ChatGPT will do something very similar from time to time. So anyways, what we're looking for is a way to compare image to image conversions, image to text conversions, text to image conversions. We want to see how much we can specify something with language in order to reproduce a highly complex and structured image and retain that. Now, for the purposes of this demonstration, we go in a slightly different direction. But you're going to see how that's going to lead to that desired goal eventually. Now, we're going to come down here. We're going to go ahead and start this guy fresh, no check marks. All the programming itself is doing, extract the IDs from those folders. Great, it's done so. And then it says, okay, we want to pull that fish data out. And it says, okay, we got some fish data coming out. We got some headers leaning in. We're keeping track of how big that image is. We're going to compress it with that API called the tiny PNG. And that compressed size by comparison is about, okay, half as much as that. It's keeping track of that as we go along. We're going to send it to the bucket through cloud services to Vision API. Why? Because if you don't, you have to convert it in such a manner as skyrockets the token use. So we're going to send that vision tagging, it's called. I'm calling it. And the Google API is going to return. It's going to say, I have noticed in your image that there is a clownfish and some other stuff. And I am pretty confident about that. We're going to use those tags and confidences, and we're going to develop an even more structured response and send that to ChatGPT for Turbo, and along with the compressed image to get as rich and targeted a possible verbal description of it and start classifying it. So here we are generating descriptions. We're sending that off. That description is going to come back to us in this JSON folder here. We're going to have to parse that out, and it's going to branch out into multiple different avenues as it classifies it according to different AP subjects, in this case, physics, chemistry, biology, environmental science. And there we go. We get that JSON response, and it's going to have a certain number of sub classifiers, and we can count those ourselves. Let's see, 1, 2 down here in between these quote marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, gee whiz, 13, 14. This is a record. I've had 10 and 11, but now it looks like we have 14. And that's excellent. Okay, so we got to start that right away. Count the classifications here, buddy. Let's see if you get 14 like we did. It did. Pre-split the rows. You can imagine what this is going to start looking like if you use lots of images at the same time. That's why we start round robining this in later rounds with the 8 API keys that we have. So we get that. And now next thing we want to do is take that JSON, bring it out and say, okay, go ahead and populate that row. Now we have an image and we have all these different classifiers. We can ask questions in that many different relevant directions. on automatic pilot with some degree of assurance. Now we're going to generate multiple choice questions down here with the round robin API calls to the chat GPT. So if you come down here, you're going to see all these API keys. And that's what we're doing because part of what we're doing also is we want to be able to conserve token use as we go along. We made the first call to Vision. We got around 300, 400 tokens there in each call. And then as we come through here, we're seeing 700, 786, about twice as many. And this is asking for rich verbal depiction and not seeing any image at all. That's taking up a lot more token power. So we're keeping track of that, and we want to use the keys so that we don't max out on anything. Now, this is going to take a minute because it has more questions than usual to go through. I'll prep you and tell you what else is going on. We're going to finalize the spreadsheet, lock everything into place once that is done, and then we're going to pair them up. We're going to pair one question with a copy of the fish so that in the end, we're going to create a second spreadsheet here automatically. It'll populate it, give everything a name match, organize it accordingly, and then we'll have basically a way to generate infinite pools of questions for basically all of the sciences. Uh, but the nice thing is about AI, I could give it a picture of my face and ask it a calculus question, and it will use the circle and it will use different proportions. It will find a way. You can give it pretty much any picture and ask it to, have it ask any kind of question. It'll do something. But doing it this way without any image at all, and by leveraging previous prompts to structure the future ones, we're hoping to find so many different ways of getting at something that we can then use that to enhance the amount of verbal structure that may be present in subsequent calls where we start to consolidate all of those things again. We're not going to get to that today, but you can see the sort of intended direction that we're going. We know it's possible, like with Grok, to capture a lot of structure and to do it reasonably well. How are we going to do that with biological stuff moving forward? Don't know. So we're getting close here, almost done. Miss you guys already. And we got 2 more rows here. So I'm going to be giving you that folder. This is like my 8th, 9th time running through and giving this sort of 10-minute spiel. I'm going to give you the folder. It's going to have everything in it. It's going to have instructions in it. It's going to be no problem. And there we go. We got that done right there. Let's go ahead and finalize the spreadsheet. Be sure to read the funny message that pops up for yourselves. Generate the final pairs. And it's going to create that new spreadsheet. And it's going to wait for a minute. Because now what it has to do, and if you got to go, I'll understand. But now all it's got to do is it's got to come over here to the, this final pairings folder. And it's going to start just creating some more fish for us. What kind of questions are we getting off of this thing? Did we read any? The image depicting a marine ecosystem featuring a clownfish and a sea anemone best serves as an analogy for which of the following aspects related to the composition of the Earth's atmosphere? Interesting. Stratification of atmospheric. Okay, great. So that's relevant. And we're going to have one question for each of these guys. You can imagine how fast this is going to fill up. When I was working before, it's hard to get your own material. Everything is so copyrighted, but there's also a lot of Creative Commons. There's a lot of public domain stuff. And there's a lot of gray area between taking an image, describing it richly and verbally, and then reversing that to create your own image when it was based in some point upon someone else's image to begin with. It was copyrighted. And I'm not too concerned about that because I'm not trying to sell anything here. But there we go. Finally, we're all good. And I hope you guys have a lovely weekend. There we go. All of our nice matches right here. Teacher and tutor's dream. All right. Thank you, guys.